So we were saying that once these parameters are satisfied, I should still verify that I am able to obtain the desired dimensions. So if we go back to the problem, they said that we want to produce a cup height of 75 millimeter with an inside diameter of 100 millimeter, while the metal thickness is 2 millimeters. First, the inside diameter of the cup will impose what? This is equal to what? In the operation, in the drawing operation, yes, exactly, it will be equal to the punch diameter. Okay, so this is dp. Okay, so initially I have a blank, a disc. The blank is in the form of a disc, and it has a diameter of here they are suggesting 175 millimeters. Okay, and I want to from this starting geometry to produce a cup with a base of 100 millimeter and a height of 75 millimeter. How can I judge if this is possible or not? What should be equal in both cases? The lateral area, okay, the surface, the area. And here, this area, the beginning area, should be equal to the final area. The final area will be the base area plus the lateral area. Okay, so I should make sure that this starting area can give me the desired height. Okay, so to do this, I will check what is the height that will result from drawing this the blank of size 175 in diameter. Okay, so here I will put the condition that my initial area is pi db square over 4. I can calculate it, while the final area will be equal to the base area, which is pi times d punch square over 4 plus the lateral area here. Okay, this lateral area is equal to what? It is function of the height, h, so it's h times the perimeter of my punch. Okay, so which is pi dp times h. So as you can see here, each value of dB will give you a certain value of the height, and the height you desire is 75. So in case h here should be at least higher or equal to 75. If it is equal, it's perfect. If it's higher, we can do a cutting operation, so we can cut just to the desired height. But if it is lower, so if you get h lower than 75, then you cannot do anything, or you can do, if you want an additional an additional step, and you should add another part to it to become, and you should weld it or do something to give you the final part. Okay, so we should, but in order to have this product from one drawing operation, then you should make sure that this blank size is enough or not. So let us check what is the height that can be provided by a blank diameter of 175 millimeters. Okay. So first, as we said, the whole idea is to set that the area is remaining the same. So the surface area of the cup should be equal to the surface area of the starting blank. For the starting blank, the area is pi d blank square over 4, while for the cup is pi dh, d of course of the punch, plus pi d punch square over 4. Then here the cup area will be function of the height. So when we set the two surfaces equal to each other, we will get the value of h. And then as you can see here, h is smaller than 75 millimeter. So you will say that with this blank size, it's not possible to obtain the desired cup. Okay. Now, who can tell me what can we do to see if it is possible to do in one drawing operation this cup? What can we do to verify if it's possible or not? How can you find with what is the minimum blank diameter that will give me 75 millimeters?
We go backward, but instead we set
Yes,
the height
very good.
75.
So in this equation, we replace h by 75 millimeters. Okay, if we do this, this will give us, so this should be equal to pi times dB square over 4. Can you check the calculation, please? If I put h equals 75 equal to pi dB square over 4, what do I get? I think we did it in the previous session. It's 200.71. Okay. So this is a logical value because when you tried 225, okay, 225 didn't work for the conditions. Then they dropped down to 175. So 20075 is in between. But let us check if it will give you acceptable parameters. So here, this is the minimum diameter that can give me the desired height. So I will check if this diameter is suitable for my drawing operation. For this, I should go back to the drawing ratio. If I calculate it here, then it's really at the limit, because if you do 200.71 over 100, it is little bit larger than 2. Okay, so even if you use a suitable blank size for to obtain 75 millimeter, you are still here. Maybe it is feasible, but just at the limit. Okay, so you can say that because it's higher than 2. Okay, and also you should check the thickness also. Okay, so you have 2 over 200. Yani also it's very close to 1%. Yani here you are just at the limit if you want. Okay, but if you want to be very accurate and if you want to say to respect the limits, it will be smaller than 1%. So you can say that no, it's not feasible. Okay, so I need to do it in steps, or I cannot do it in one drawing operation. Okay.
Doctor?
Yeah.
So إذا بدنا نشوف إذا feasible or not بدنا نعمل كل يعني نعمل الريشيو ونعمل تبع الثيكنس
Exactly. مظبوط كل شيء. بس إذا واحدة من الكونديشن not satisfied, you can stop. Okay. يعني if the question was just it is feasible or not, بس يطلع واحدة مش ظابطة, you stop. هلا here because A, B, C were satisfied, يعني ال DR, ال R وال T over dB conditions كانوا مقبولين. So the final condition is to check that it's possible to get the final geometry or not.
Yes, okay. وإذا كانت ال H أكبر بنقول كمان أنا feasible.
Yes. Yes. Okay. لأنه you can trim it, يعني you can trim the exceeding part if you want.
Yes, thank you.
Any other question? Okay, guys, so we are done with chapter 16.